Morning, good afternoon, good evening, everyone. Welcome to the second in our series of 2 webinars, specifically focusing on the return to the workplace. Last week, our first session looked at travel and vertical transport, i.e. how you get up and down your buildings when you might get to your workplace or your conventional workplace rather than your home workplace. This week, we're looking at what happens when we get into the workplace. Obviously, we're meeting really challenging times. COVID still carries on. There are some signs of easing of restrictions in European countries, in Australasian area, in Asia, and we'll wait to see how things develop over the next few weeks and what the return to normal might look like. Today, we've got a panel of 3 speakers, so I'll get on and introduce those to you in a second. We've got a presentation of about 30 minutes long, will followed by a series of question and answers. There's a Q&A box to the right-hand side of the screen, and there's a chat box, so please feel free to put in your questions. We'll do our best to answer them. If we run out of time, we'll email you the answers afterwards. Certainly in last week's session, we got a good session of Q&A going at the end, and that's what we want. We also want to learn from you. You'll have ideas, you'll have knowledge that we can all benefit from, so together we can all learn and develop a better working environment going forward. 3 speakers today, so we're up in the ante. Who's the most we've had before, but we've got 3 people all with something to say. I'm not sure what order they are on your screen, but on the order on my screen, we'll go through Kavita at the top. Kavita, all were members of our sustainability team in Condal. Kavita has a particular focus on healthy workspaces and communities. Kavita has been involved in extensive research into green and healthy toxic material transparency, sick building syndrome, and biophilia to improve the internal environment and enhance the interaction of people with living things and the natural surroundings in the workspace. Then Curtis has been with Condal for a couple of years and has a particular great contribution in the sustainability team, looking into research into indoor air environmental quality and looking at lots of our ongoing projects in that respect. He's got an environmental health and chemistry PhD and is a member of the CIBSE knowledge panel and also part of the air quality working group. Ed leads the Condal research and development group in the practice, looking at all sorts of things like digital tools, futures, impact of technology on the industry we work in, sustainability, indoor environmental air quality, and technical best practice. He also keeps busy by chairing the CIBSE Air Quality Working Group as a member of the CIBSE Knowledge Generation Panel and contributes to the Construction Leadership Council on all these related matters. So very busy, plenty of things they can all let you know about. So without further ado, I'll hand you over to our panel of speakers. Well, I'm not sure who's running first, but hand you over to whoever's taking over first. Look forward to an interesting discussion. Look forward to the question and answers at the end and getting a bit of dialogue going with everybody. So please raise your questions as we go through and we'll try our best to answer them. So thank you and enjoy the webinar.
Thanks, Thomas. So I'll very quickly introduce Condal for those that haven't met us. We are an established practice. We've been going since 1976 now. Started in the UK, expanded around the world, down to Australia, Asia, other parts of Europe and the Middle East. We're approaching 1,000 people globally, across 950 offices now in the crazy world we're currently living in. We have won lots of awards. And we're aiming to be carbon neutral this year, so net zero carbon by 2020. These are the markets that we operate in. As I said, we're primarily UK from our background, but have expanded to Asia. Particularly, we've tried to bring some of the things that we've learned from our other offices into this talk. So obviously areas like Hong Kong, Shanghai, Singapore have faced the problems caused by COVID before we have, and so we're able to look into the future a little with some of that experience from our own offices. So the talk today, as Thomas mentioned, covers indoor air quality, a bit about monitoring, things to do with hygiene and the kind of things that we've learned from Kavita will cover. But first of all, Curtis is going to give a little bit of background into COVID that kind of sets the scene for some of the measures that we'll recommend and talk about today.
Yep, thanks, Ed. So unfortunately, COVID-19 is unlikely to be the last of its kind. So the question this presentation looks to ask is, what can we do to protect our buildings now and future-proof them for subsequent viral outbreaks? There we go. Sorry, technical problems. So we should all be following national and governmental advice and advice from the World Health Organization as well. This here is from the UK government advice, but nothing we can do in the building would be as effective as these policies that have already been set out. So the idea is to seamlessly integrate these policies into the building with as least disruption as possible. Now, as Ed mentioned, Kundal is really a global company. So we've learned many lessons from some of our other offices, ones who've been through pandemics before, or ones who are slightly ahead of us in this current pandemic. But many of the things we're going to talk about today will be short-term measures. And whilst there will be undoubtedly be long-term impacts learned from these other countries, it's suggested that these will be more limited to hygiene and public health approaches, opposed to long-term building changes. So there's an array of industry guidance out at the moment, and this is really designed to reduce risks when government advice is already being followed. Most of it's based on existing viral science that we already know, or sort of evidence from healthcare settings. So what do we actually know about COVID-19? Well, as this graph shows, it truly is a global pandemic, and it's directly affecting everyone. There's not many countries there in the world that haven't got at least one case. And it's similar to seasonal flu in some ways, such as it's transmitted person to person and people have similar symptoms. But unlike the flu, no vaccine or specific treatment is available. And it seems like COVID-19 actually may be more transmissible. And as this is a new virus, no one actually has immunity and everyone is susceptible to this virus. But how can we catch this virus? So there are a number of transmission pathways that I'm just going to run through quickly. A really designates droplet transmission. This is where an infected person, such as the gentleman here, exhales infected the droplets by speaking, talking, for example, and then someone within a close distance will inhale these. This is the reason the two distancing guideline has been put in place, or 1.5 meters in some countries. And then B over there is really looking at airborne aerosol transmission. This is where someone exhales particles and they remain in the air for a number of hours. I'll talk about a study next that suggests this. And this is the problem where someone has walked into an area and then someone who doesn't have the virus walks through and inhales the particles that are there in the air. C is talking about surface transmission, and this is where someone infected touches a surface, and then someone else comes along and touches the same surface, then touches their eyes, nose, and mouth. And there's also the fecal-oral transmission route, which is where someone can become contaminated someone can pick up the virus from contaminated feces. And it's important that public drainage and public health systems and drainage systems are working as designed. So the lifetime of the virus is really, really important. Obviously, this is what's taking our risk of how we're going to get infected. So this graph here is showing the original SARS virus on the bottom and the new COVID-19 on the top. As you can see, they do have many similarities, but I want to focus on COVID-19 specifically. And in the top left graph there, you've got aerosols. And this is what it's talked about with the aerosol airborne route, where this is how long the virus can survive in the air. And from this study, it was at least 3 hours, which is quite a long period of time to remain in the air. Obviously, this is done in a lab study, and it doesn't reflect sort of necessarily what would be in real life, but it's a good example of how the virus lives. And then you've got other 4 surfaces here, where copper, where it's really a small number of hours, which it lasts on. Cardboard can be up to 24, and then you've got stainless steel and plastic can be as much as 72 hours. Now, Kavita is going to go through the different materials and what we can do to optimize them in our building a bit later on in the presentation. So I'm just going to do a day in the life lockdown version of contamination, just to show really how easy it is to still be contaminated in the phase we are now, and how we'll need to consider this moving forward. So for example, just leaving the house in a communal building, such as apartment blocks or shared housing, obviously the handle and the lock may be contaminated from someone infected touching it. And similarly in the lobbies, corridors and lift areas, you've got that suspended particles in aerosol that someone could come along and inhale. A simple thing such as taking the bins out now, this can be considered a high touch area in areas where these are shared. And these may have been previously contaminated by another resident, and then you go along and touch the same surface. A simple chat with neighbours, especially not so much externally, but especially internally. It's important that we keep that 2 meter distance to prevent droplet transmission, but also you've got airborne aerosol transmission being a risk as well. Now, many of us are having parcels delivered, but even non-contact delivery, the virus, as the previous slide suggested, can remain on surfaces for a number of hours. Now, there is one caveat to this, that the viral load may not be sufficient to actually give you the virus, but even though it's still present on the surface. So it's important that we take care as much as possible in this, removing external packaging, etc., and disposing of it as soon as possible. Now in the UK, we're allowed to take unlimited daily exercise, and the risk outside is much lower because outdoors is a much more dynamic environment than inside, and particles are often blown away by wind, for example. But care should be taken not to touch surfaces, for example, when we're outside, and then touching our face, nose and eyes unconsciously when running. But we can, there has been some good news. A recent study came out suggesting that sunlight may kill off the virus in a number of hours. So this means that outside the risk may even be lower. Now, most of us, this is the main place where we're likely to pick up the virus, is the supermarket. Obviously, you've got the queues outside the supermarket, but this is an external area. And if people are 2 meters apart, the risk should be generally low. However, as many of us know, as soon as we enter the supermarket, the 2 meter rule often seems to go out the window. There's very close proximity to different people. Within the space, there's an unknown ventilation and obviously a large amount of contaminated surfaces. And then when we return from the supermarket, obviously the bags and the products that we've used can still be contaminated with the virus. Now, the same goes for the previous comment I made of the delivery. The viral load may not be enough, but it's important that we still take care to protect ourselves. Cleaning with antibacterial wipes or spray may help, but it's not proven as of yet for COVID-19. And you've got the same issues if you get a takeaway in the evening, for example. The risk from the actual food is unknown, but it's suggested to be quite low because it's been cooked, and you can always re-microwave to ensure that the risk is even lower. But all packaging should be removed and food emptied onto plates to remove any risk. Now, the idea of showing this is just to show how many places we can still become contaminated with the virus, even in this lockdown stage. So it's going to be even more important when we start to move back to work to consider this. And what is the process behind us actually being able to move back to work? Well, there's several steps that are going to need to be achieved before we can re-enter. The first one is being legislation or governmental requirements. Here in the UK, we're still considered, if you can work from home, it's still been suggested that you should work from home. You've also got transport. This was covered quite dramatically in our first webinar, where we talk about the reduced capacity possibility and how people may be cycling or running into work or walking instead. And has the landlord prepared the building effectively? Have they put in policies in place, screens, for example, to protect people with appropriate PPE? Is the plant and ventilation system running effectively? All these things need to be considered. And then you've got communal area agreements, such as where we sit to have lunch. Is it going to be one person per table? In tea points, for example, are they going to be able to be used? There needs to be agreement, they're high touch service, needs to be agreement in all these areas, for example. And then you've got the tenants' readiness as well, where have there been policies put in place if someone becomes ill? Has the local FCU, for example, is it working effectively? And then the last one being an individual's actual willingness. There's obviously a lot of anxiety about people coming back to the office, and are people actually willing to do so? So now I'm going to pass over to Ed to talk specifically about ventilation and air quality considerations.
Thanks, Curtis. So air quality, beyond the recommendations that the government put out, has historically shown to be one of the main transmission pathways. That was true of SARS, where issues with airborne viral particles caused specific outbreaks in apartment buildings. But it's also one of the things that is, as somebody that operates or works in a building, it's one of the things that you can do to reduce risk. It's not going to eliminate it entirely, but it will help. So recapping on the transmission pathways that Curtis has spoken about, this is an adaptation of an ASHRAE healthcare guidance. The 1 to 2 meters covers effectively the range of droplets when coughed or sneezed. So that's the research suggests that is the strongest route of transmission from person to person. So the research backing up that droplets containing the virus will likely or produce the highest risk of transmitting the virus. That's pretty good science. But whilst that person's coughing, whilst they're talking, if they're singing, there's a more complex process happening to the virus that produces smaller particles, either droplet nuclei or aerosols, which an increasing amount of research is suggesting will also produce a infection risk. So the things that we can do in ventilation can help to address some of those problems, and I'll talk you through those now. So the first one, as I mentioned, is droplets. So really, once you've maintained your social distancing, you've kept that 2 meter distance, the droplets will either fall to the floor or fall on a desk, and at that point it's being dealt with by hygiene measures and not air quality measures. So there is some risk of evaporation of those droplets and generation of aerosols, but that's relatively small, and if you're regularly cleaning, then you can deal with it. So the one that's more important from an air quality and from a ventilation perspective is aerosol transmission. So the problem with the risk of aerosol transmission is that it's very difficult to prove that aerosols are responsible for an infection in the space, partly because there's so many confounding factors in that space, in that situation. But as Curtis highlighted earlier, it's been found that COVID will survive as an aerosol for 3 hours, just suspended in the air. So the reason there's a picture of bubbles, I was trying to explain to my wife whilst talking in the kitchen and blowing bubbles for my child, and it became quite obvious how far a bubble, when you blow it, can travel, and a bubble is heavier than air. So effectively, if you, without any kind of extract or kind of dilution of the air, the bubbles can travel easily across space. So our main tool to deal with this aerosol transmission, this build-up of viruses within the air, is ventilation. So the way I found easiest to understand how the virus is building up in space is kind of how we breathe normally. So a healthy person is always breathing out. They're always exhaling CO2 and various other kind of bioeffluents, as they're called, into the space. If you don't ventilate that space, they build up and your CO2 levels start to build up. And at a point that environment starts to feel unhealthy. Now, when COVID comes into play, you've got all of those things happening as well, but then you've also got the viral load. So if you've got a room with 3 or 4 people that have that are asymptomatic, that are carrying COVID, and are happily talking away, even if they're socially distanced, they are still releasing an amount of virus into the atmosphere around them. So as building services engineers, the way we approached the previous problem works exactly the same for COVID, and that's what the guidance from SIBSI, from ASHRAE, from every building services related organisation suggests, which is that you dilute that load as much as possible with clean outdoor air. So there's some things that will probably be happening anyway, which will help you with that, in that the occupancy to your building will likely be reduced in the short term. So that gives you a bit of room to play with in the capacity, but the recommendation is that there is no upper limit to how much air you should supply. So it's as much as reasonably possible. And that's just to reduce the risk. The more fresh air you provide, the lower the amount of viral load in the space. So beyond that, there's some other recommendations about the actual operation of the system that will kind of optimize that. So to again reduce and to increase the dilution rate, if you can run your systems 24 hours a day, 7 days a week, or if that's that will have an energy penalty. So if that's too harsh, then maybe 2 hours before occupation and 2 hours after, so that you have a chance to purge anything that may have been hanging around in the space out of the building. If you've got demand control in your building, then setting that low so often that will be controlled by a CO2 sensor. If you set that nice and low so that it's trying to push as much air in to dilute the CO2, when you've got people in that space, that will ramp up the fans and provide more air, again reducing that risk. And one thing to avoid when you're returning to work, it might be tempting to only open part of the office and ventilate that. Try to avoid doing that. Keep people spread out, because it gives more air per person over a bigger area, which means it's easier to dilute. So if you don't have a mechanical system, or even if you do, then opening the windows will achieve a similar effect. SIBSI, they have produced quite detailed guidance on the different modes of ventilation that are suitable for your different types of buildings, and I'd recommend having a look at that. If you can cross ventilate, so if you can open windows on 2 facades of your building, do that. You'll get a higher fresh air rate through there. And the problem with windows is it's hard to control. So your staff might moan about being a little bit cold or a bit hot in summer, but the idea being to reduce the COVID risk in the short term before things hopefully go back to normal. So as I say, you can do that with mechanical ventilation. There's no harm in providing extra air, except as I say with the thermal comfort. So another one that's fairly key, it's not been proven yet that COVID has been transmitted through recirculation across a large building, but there's emerging evidence to suggest that in smaller areas there is a level of recirculation. So apologies for the schematic diagram for those that are non-technical. There's not any good Shutterstock images of recirculation circuits on air handling units. The principle is that in particularly variable air volume systems, you have a mixing route where the shared return air, which can come from a number of floors, a number of areas of the floor, is mixed with fresh outdoor air to reduce the amount of heating or cooling that you have to supply to that fresh outdoor air. So you're using some kind of treated air to save a bit of energy when you are providing the fresh air. The risk of that is that you then create a risk of stale, potentially contaminated air from one area of the building to another. So it's quite an easy fix if you're in FM, or if you're running buildings talk to your FM teams. You effectively just need to close a damper. That can either be manually, it could be through the BMS. The main thing is to remove that recirculation risk. There are potential unintended consequences because you're having to deal with outdoor air, which could be a colder temperature than that recirculated air. Then your heating or your cooling system will have to work that much harder. It's given the time of year that we're in the northern hemisphere, that in northwestern Europe, that shouldn't be too much of a risk. It's relatively mild at the moment, but so there should be a bit of capacity in your systems, but you should probably check if we're still in a similar situation in peak summer, then there might be some issues. The second risk with central plant is thermal wheels. So this is effectively another heat recovery device. It's a spinning wheel that takes heat from the outgoing air path and transfer it to the incoming air path. The risk with this is that there is leakage from one side to the other. Generally, there's a little bit of debate about this in the industry about whether you should actually turn it off. REVA suggests don't turn them off because you actually increase the risk of leakage across the two. In general, this one is a little bit harder to deal with. It's not just a case of on or off. It's about analysing a pressure difference between one side of the system and the other. And really, you need to take those measurements to make sure that there's no air leaking from one side to the other, and get a qualified engineer who knows what they're doing to do that if your FM team don't feel confident. So one of the problems that's fairly specific to the UK market is fan coil units. So I mentioned earlier recirculation. Fan coil units sit above your ceiling and recirculate air locally. Again, there's a bit of debate over what's better to do with fan coil units. In terms of SIBSE's approach, they believe that having them on allows a better distribution of air around the space. So when you're providing fresh air, keep your fan coil units on because it can distribute that fresh air and make sure that you haven't got any pockets where it's not diluting. REVA, I think that's probably the more sensible approach. REVA suggests either turning them off entirely if you can, because you're not bringing anything, you're not recirculating viruses within a room, for example, but that's only really going to be possible if you can open windows and keep cool. So for most offices, that's probably unlikely, but if you can't do that, then to run them 24/7 again, so that you don't have deposition of viruses within the fan coil units, and that you can actually keep that dilution rate going. So we've been asked a few times about temperature and humidity and what we can do about that. Again, there's some evidence that humidity, having the right humidity is good for reducing risk of catching viruses, because the mucous membranes in your nose don't dry out, and it finds it hard to evaporate. REVA and have kind of raised some evidence that suggests that the viruses will evaporate anyway, as a part of the kind of physical process of coughing or sneezing, so that changing humidity won't have much impact. And in terms of temperature, the virus is extremely resilient to both heat and cold, so don't think about doing anything much other than keeping your set points roughly where they were, to be honest. Changing them either way. If you've got humidification in your building already, you could consider using it, but again, if you're in the northern hemisphere around this time of year, your humidity should start to drift back above 30% towards 40% anyway. Again, cleaning ductwork, there's no evidence that additional cleaning of ductwork has any benefit. There's no evidence of any transmission from droplets landing in ductwork and then getting resuspended, so that's unnecessary. Filtration is a little bit tricky, in that there are filters which will filter out the virus, HEPA filters from healthcare kind of environments. The issue with those kind of filters is that they tend to get blocked quite easily, because they're so high efficiency. They increase the amount of resistance that most fans in your system, and most fans won't be able to deal with that additional resistance. So really, the guidance around filtration is to keep with your normal maintenance plan. So what you might find, and your normal quality filters, I would suggest that having a review of your filters. We've done kind of back to work surveys with our clients, and we found that actually their filters and the specification for their filters is below par from an air quality perspective, and that means that it's kind of below par from a health perspective generally, but also for COVID. So review your filter spec. If it's up to current best practice standards, you should be fine. You don't need to go beyond that. And putting in a kind of HEPA filter in recirculation type systems is probably not going to work in a fan coil unit. You don't have the power in the fan to actually make that work. Another one we're being asked a lot about is air cleaners. So these are an additional device, a box that has some sort of filter in them that will then clean the air in that space. There's a lot of variety across the air cleaner market. Some of them work quite well. The mechanical ones with HEPA filters, as I've just described, work well. Electrostatic also tend to work well. The other ones, there's not a lot of certification around the performance of these air cleaners. So it's very difficult to judge one against another. So if you do want to use them and they're useful in enclosed spaces where you don't have ventilation or you have not particularly large areas to treat, then look for independent testing. There is an emerging standard, but it's not out yet. But that independent testing, any kind of lab results from universities that back up the claims, particularly the air volumes that they cover, then look for that. Also, some of them can produce, the lower quality ones can produce byproducts that are bad for air quality unintentionally. So make sure that you have very strong assurances that they're not doing that. As mentioned earlier, there are some unintended consequences of taking these measures, so these should be seen as short term. One of the main ones as we roll into summer is thermal comfort. So it may be that we end up getting a bit hot because we have to provide more air and that outdoor air is warmer. It's something you need to explain to the people within your building or be prepared to get used to, and that's going to be kind of through dressing. In terms of energy performance, it is likely to go up. We need to keep our eye on net zero and again treat this as a temporary thing. So our operational energy, if you're running fans 24/7, is likely to go up. The main thing is to keep an eye on it, so that when things do get back to normal, we're able to put the systems back how they were and start saving energy again. In terms of air quality, because you're providing lots more outdoor air, there is a risk to worsening air quality in terms of particulates, in terms of the other types of air pollution that exist due to sort of traffic and things like that. One of the benefits, slim though they are, of COVID is that the air quality has improved, particularly in cities, as traffic has reduced. So hopefully that means that that risk isn't too high. And finally, the question that we're asked is fairly often is whether you can actually measure COVID in the space. So one of the things that we do quite a lot is air quality monitoring and testing of monitors. And the answer is not directly. So as I mentioned earlier, you can measure CO2. You can use other proxies that will give you an indication of how well you're diluting the viral load within your space with outdoor air. So we can certainly help you with the kind of devices that will give you an indication. It is possible to find whether there's COVID within a building from swabbing it and testing RNA and doing other things in the lab. We're working with Northumbria University and Hub for Biotech in the built environment, who can find the presence of a virus. The issue is that you can't actually tell whether that virus is active and liable to infect someone. So the answer is no, you can't really measure it directly. You can measure the presence, but it could have been there at some point. And the things that you can measure, which are worth measuring, is how much fresh air you're providing, and long term you can use that as a way of saying to your staff, yes, we have upped our ventilation rate, and as a result the systems and the building is as healthy as we can make it. So my closing message is around that net zero point, and that's when the all clear is sounded, don't forget to put things back how they were. If you run your systems like this all the time, when there's no viral load, you're going to be massively over ventilating your spaces, and your energy will suffer as a result.
Thanks, Ed. So I'm now going to talk about occupant considerations to ensure that people are safe when returning to the building, and also that measures are in place to help them feel reassured and that they want to do so. So I'm going to do another day in the life about an occupant's return to the office. So this was covered the entry to the office was covered quite a lot in part 1 of this webinar, which is available on YouTube now. And when it was calculated for our own office, it was suggested that if everyone turned up at 9 o'clock in the morning, or for our building, sorry, there'd be a 1,300 meter queue and approximately a 5-hour wait. So obviously that's not really a viable way to enter the building, and that is because of having to keep the 2-meter distance. So there's likely to be sort of staggered entry times on that front. But once that's all been sorted out, what we should have when we enter is automatic doors to ensure that we're preventing touching contaminated surfaces that have been used. Screens should be put up to protect everyone, including entrance staff. Obviously, they're going to be interacting with a lot of people, and then other occupants and visitors. And then considering also temperature screening and appropriate PPE in the entry lobbies. Now, again, with lift lobbies and lifts, this is again covered in part 1 of the webinar, so I'm just briefly going to go through it. You obviously got the issues around contamination with high touch surfaces. The things that need to be considered are sort of queue management while queuing for the lift, ensuring that the distancing is still in place and adequate signage will be there. And then also, what is the safe passenger limits to place inside the lifts, and that distance protocols are kept in place. Now, it's likely that attendants are going to have to manage the flow of people and overcrowding. And if there is a one-way system where, i.e. you use the lifts to go up, for example, where possible, and the stairs to go down, they need to ensure that this is going to be adhered to. The next point is with the likely reduced capacity of public transport in areas where this is much more relied on to get to the office, there's likely going to be a lot more people cycling and walking. And that's for safety reasons as well, people not being comfortable getting the tube into work, for example. So it's likely that more cycle spaces are going to suddenly be required. At the moment, offices are designed for quite a low number of the office to come in. If suddenly 50% of the office want to come in, where are we going to put all those bikes? And at the same time as that, more people may run into the office or walk further distances. So then we'll possibly need the changing facilities to also consider distancing rules. Are they going to be suitable for that? If the showers within these facilities, are they going to need to be more regularly cleaned? Are they going to be able to be used at all? That's things that need to be considered building by building. But once you change, for example, and you come up for your morning coffee and breakfast, you've got the issues around common items, such as common cutlery being used, mugs, glasses, and then you've got coffee and tea holders, for example, and the fridge and the milk. All of this is going to be really high touch surfaces. So you need to ensure that the use is definitely minimized or effectively used as possible, but even possibility of not being able to use them at all. Now, mail delivery is something that runs on the business, and that's usually where a staff member would come and deliver the mail. But due to sort of being close distance to each other and also surface contamination, we need to look into sort of other techniques such as digital mail delivery. This would be where mail or packages would be placed inside a digital locker, and then occupants could be notified via email when they're able to collect. And with this method, we can consider a delay time. As I mentioned previously in the presentation, cardboard, for example, the virus can last up to 24 hours. So should we leave parcels within the locker for 24 hours to ensure that there's no virus on them by the time they're collected by a member of staff? Toilets, these are obviously going to be a very high use place and quite an issue to deal with in the offices. In terms of systems, it will be putting in systems to discourage flushing with the lid open. This can cause particles to become airborne and become quite a risk inside. So there's certain systems, as we quite often see on toilets that in trains that do this. But also the use of smart technology should be investigated. That is footfall and occupancy counters, and also maybe displaying this outside of the toilets to ensure that people don't walk into the toilets and accidentally breach social distancing rules because they're not sure how many people are in there. In terms of lunchtime, there's obviously, as I mentioned before, there's the fridge and zip taps. These are going to be really high touch surfaces and they're going to have to be really regularly cleaned. If there's a specific catering facility in your office, it's going to be trying to reduce the use of self-service foods, where it's obviously contamination is more of a risk, but then also considering pre-packaged only items and encouraging staff members to bring food from their home to reduce risk as well. Something that probably everyone's going to have to consider is that the lunch hour is going to have to be extended. And the break's going to have to be staggered either by team or by areas of the office to ensure that there's not mass overcrowding in the tea points or the catering areas. Now, printing is another issue that where the printers are quite often enclosed in spaces due to air quality considerations. So you've got that being overcrowding there as well as a problem, but also the fact that printers have often got touch screens, and again will be a high contact area. So should we be considering assigning designated staff to actually use these printers and then deliver the paper to pigeonholes or locker systems to just prevent further contact? And as I mentioned before, when we're leaving the office, if we're going to put in a one-way system, then the stairs are probably the best to go back down where this is possible, and to investigate if the building has got a secondary stairway, for example, that can be used which is not normally used, but could be used to reduce overcrowding. And how can we utilize smart technologies, again, sensors and displaying that to track footfall and occupancy and try and reduce overcrowding on the stairs. But it's likely that if we're going to have staggered entry to the building, that we're also going to have to have staggered exit as well. Further considerations I didn't put on that would be required. If appropriate PPE is being provided, then the staff need to be trained in how to actually use this in terms of masks and gloves for disposal of gloves, for example, but also risk training, sort of risks, in identifying risks in the office of COVID-19, how we can minimize these risks. And this maybe should be delivered digitally online before staff actually return to the office to ensure that they've already received the training. And then this is going to be commonplace through offices, is appropriate signage, reminding everyone to wash their hands regularly, and then also ensuring that people are 2 meters apart. And what is the procedure? Then you're going to need to be procedures in place if someone contracts COVID-19 in the office. What happens to the rest of the staff members? What's the procedure for the person in question, but also everyone else to ensure that safety is at the forefront? So I'm going to now pass on to Kavita to speak about hygiene and material considerations.
Thank you, Curtis. So as you all know, every building and space is different. We also need to think about contact surfaces as they present potential for transfer of germs and viruses between people. Occupants can be exposed to infection by simply touching contaminated surfaces and objects, and by then touching their mouth, eyes, and nose. This can lead to a single occupant contaminating numerous spaces throughout the space, just through touching multiple surfaces such as the door handles, countertop, lift buttons, and mobile phones even. With both scenarios, the material of the surface itself and the environmental conditions such as the fresh air ventilation, the air movement, the circulation of the air within that space affect the outcome of this risk. Therefore, effective strategies in the form of contact-free access, appropriate surface selection, regular cleaning and maintenance protocols, signage, it's all about educating people, right? And can aid with mitigation of the spread of germs and viruses. I will now share some examples of practices which can be considered in your building and workspace. For example, touch-free movement and devices. Curtis mentioned earlier, to reduce this risk, touch-free movement can be created by, for example, having automated doors, especially between the routes from the bathroom and the hand wash facilities in the kitchen or the canteen facilities, or even the office accommodation. This is quite relatable if you think about it. In the bathroom, you would touch the sink tap, the soap dispenser, the button on the hand dryer, then the bathroom exit door to the lobby door to the kitchen, or the communal area, buttons on the coffee machine. These have all been touched by others before, and so on and so forth. Also, touch-free devices, where feasible, install sense taps and soap dispensers, install this in kitchens and bathroom areas to further reduce contact. Moving on to material choices. There are a lot of surfaces in our workplace. Fundamentally, where feasible, we need to minimize contact with these surfaces. As Curtis was saying earlier, we know the viruses such as COVID-19 tend to decay faster on copper or brass surfaces than on plastic and stainless steel surfaces. Consider replacing these materials that support virus longer, namely plastic and stainless steel, with copper and brass, which are well known for their antimicrobial properties. If stainless steel and plastic surfaces are still preferred, then more regular and intense cleaning and maintenance protocols need to be implemented. In terms of countertop, as an alternative to brass and copper, engineered stones such as coil and quartz, solid stones such as granite, or even solid hardwood can be alternative healthy options. Look for products that have low absorption rates and that are mechanically polished rather than chemically sealed. If coatings are required, consider safe coatings or bio-based polymers made from natural products such as soybean, for example, corn, or even natural-based products as they do not contain formaldehyde. These surfaces should also be abrasion resistant, non-leaching, and meets testing requirements for antimicrobial activity. Antimicrobial activity in surfaces can accelerate the natural rate of microbial cell death. Non-leaching antimicrobial surfaces are capable of killing microorganisms upon contact without leaching significant amounts of microbial materials into the surrounding environment, which is great for reducing the impact on the air quality. Be mindful of non-natural or green surface treatment, as these can off-gas chemicals, again, detrimental to the indoor air quality as well as the occupant health. If you're looking at healthcare premises, ensure these products meet the UK HDM standards or even the HPA standards in the US. Again, it is recommended that high touch or non-porous surfaces meet the following requirements: smooth and free of defects visible to the unaided eye, finished to maintain smooth welds and joints, and free of crevices or other hard to reach places, so that you can clean properly. Moving on to cleaning strategy and equipment. High touch surfaces present increased risks for contamination, particularly in high transit areas. A cleaning protocol must take into account the degree to which disinfectation and sanitization are necessary. Surfaces exposed to frequent human contact can harbor lots of microbes and toxins for extended periods of time, as Curtis mentioned earlier. These surfaces can be kept sanitary if they're designed with suitable materials, such as some suggested above, that facilitate easy cleaning. This reduces the need for cleaning products that contain potentially toxic chemicals. Any products or equipment which are used in this space, is recommended that they meet the Public Health England guidelines, for example, or EPA in the US, but also you can use principles taken from the Well Building Standard. For those of you who are not familiar with the Well Building Standard, this is a standard, this standard is a health and well-being assessment tool where the criteria has been derived from extensive medical and scientific research. It is a good place to start if you're looking to create a clean and healthier workspace environment, and it can be applied to any other occupied spaces. These standards recommend low VOC, low toxicity products are used so as to not cause detrimental impact on your indoor air quality. It also recommends that mops do not have to be wrung by hands, and vacuum cleaners contain filters with HEPA ratings. Therefore, a building's cleaning protocol should be reviewed on return to work. This should be clear and thorough, following guidances of bodies such as Public Health England and the CDC, paying special attention to high contact surfaces. The frequency of regular cleaning should be increased from normal operating procedures and clearly visible to reassure occupants. An effective cleaning protocol must consider equipment use and staff training. A building's cleaning practice must include and be evaluated to incorporate the following principles. You have to maintain a list of high-touch surfaces, and you need to educate the cleaners to limit disinfectation to high-touch surfaces, certainly. Alternative, cleaning processes and equipment that use short wavelength UVC light, ultraviolet light, effectively can reduce bacterial load on surfaces. So as long as they use with sufficient frequency to prevent the bioload from this being reestablished. Again, cleaners need to be educated on how to use these devices. You need to strictly follow manufacturer's recommendation, and spaces should be disinfected out of hours. In terms of cleanability, again, if you're looking at the new space, make sure there's no permanent wall-to-wall carpeting. Everything should be removable, so removable carpet tiles, removable rugs and hard surfaces where feasible. The building must provide adequate flexible storage space for all permanent and movable items to allow high-touch surfaces, so any surface, to be completely cleared and cleaned during cleaning processes. Right angles between walls, windows, floors, kitchen tops must be sealed to aid cleaning more efficiently. Once these protocols are in place, indoor environmental quality monitoring is recommended. so you know what's happening in your space, and it also provides further assurance to the occupants within the space. If you're looking to supplement your building's high-risk areas, where there's not enough ventilation, for example, suitably sized portable air purifiers with appropriate filters may be effective at controlling airborne particle concentration, but I would be mindful about what Ed mentioned earlier and to follow some guidance or advice from professionals. Again, in summary, enhanced cleaning and disinfection protocols must be paired with enhanced ventilation protocols. This is so that you reduce exposure to toxic VOCs from cleaning products and reducing airborne transmissions. Moving on to procurement of cleaning products. So as to maintain a clean space, safe ingredients that optimize human and environmental health should be considered. Indoor air quality can be degraded significantly by volatile organic compounds and VOCs that are off gas from paints, finishes, coatings, as a result of use of harsh cleaning products and aerosol sanitizers. Also, harsh cleaning products will leach and destroy natural or bio-based materials and product surfaces. Again, VOCs include benzene, classified as a human carcinogen, formaldehyde, other chemical compounds, which are in high concentrations can lead to irritations of the nose and lungs and have been associated with increased asthma and other respiratory disorders. It is known that VOC levels, can be up to 5 times higher in an indoor space than an outdoor space if the space is not ventilated correctly. Therefore, staff with allergies or anyone with compromised immunorespiratory system will need to be considered when using harsh sanitizing or cleaning products in occupied spaces. In the UK, green cleaning products such as Method or eCover or any product in an EU label or an allergy label equivalent are fine to use. You can also find hazard profile products on the bottle, on the ingredient list on the bottle. Also to request a safety data sheet from the product website, or even seek advice as to which is the most safest and most effective to use. It is best to clean more often and more intensely than relying solely on cleaning products to do the work for you. Also, with growing concerns of the spread of coronavirus, more people are turning to the power disinfectants to clean surfaces. Although ordinary soap is surprisingly effective at breaking down the coronavirus, bleach, alcohol, and ammonia are all rising in popularity and are the consequences of accidental poisoning. The oxidizing potential of bleach, bleach is such an effective disinfectant, also makes it a chemical agent. Again, when it interacts with your internal workspace or internal occupied spaces, it reacts with other chemicals and creating toxic compounds such as chloroform even. If you must use bleach, use it in accordance with the manufacturer's instructions. In any room you use it, ensure that it's well ventilated and wear gloves to protect your hands. And whatever you do not drink or ingest it at any concentration. While it is tempting for hospitals, in a healthcare environment to use antimicrobial products in lieu of other cleaning products, guidance suggests this is not a good idea. It's better to keep the facilities clean, thoroughly maintained, and the HVAC systems to be thoroughly maintained to reduce the spread of germs. Moving on to personal hygiene and support and self-cleaning. Again, hand washing is one of the most important and effective means of reducing transmission of pathogens. Regular rinsing with just ordinary soap and warm water helps to reduce the spread of unwanted and potential dangerous germs. Therefore, look to promote regular and thorough hand washing through appropriate signage within the workspaces in the bathrooms, in the kitchen, as well as other initiatives such as providing hand sanitizers at regular intervals or in high-touch areas such as communal areas, reception, lift lobbies. Interestingly, research showed that bathroom personal hygiene differs from person to person. This can range from a 2-second rinse to a 2 minutes hand wash to no washing of hands at all after using the bathroom. Limiting the impact of this pandemic will require an all-in approach. Therefore, it is vital that everyone tries to adhere to the recommended 2-minute hand wash rule where possible. Also, medical bodies advise that washing hands frequently with ordinary soap and warm water is effective at combating any illness causing germs, not just coronavirus. In addition, using paper towels to dry hand is more effective in removing bacteria or viruses than using hand dryers, air dryers. Since liquid soap is, in bulk refillable dispensers are prone to bacterial contamination, use sealed liquid soap cartridges is recommended. Again, going forward, buildings should look to explore the feasibility of creating hand cleaning or sanitizing stations in entrance lobbies and next to areas intended for food consumption. Within the workplaces, employees are also providing, should provide disposable self-cleaning and disinfecting products and occupants to clean and wipe down their own workstations. Moving on to sink dimensions, again, hand washing sinks, you need to provide sufficient room to wash your hands without touching the sink sides and without any splashbacks. Again, replace hand dryers with paper towels to prevent flow of contaminated air. Again, if you've been to any of our Kundal well talks, you will know that the use of paper towels, the art of rubbing your hands together, removes any residual dirt and contaminant. Moving on to sanitation and legionella risk. Our PH colleagues will tell you in most buildings there's a sanitation maintenance plan in place. However, the key thing to remember is to ensure drains are checked and primed for safe use before re-entry into the building. Legionella assessments, need to be carried out in accordance with Health and Safety Executive guidance before they're occupied, as the buildings have not been occupied for long periods of time. What you don't want is to survive coronavirus and then catch Legionella disease instead. And lastly, hazardous waste. Whilst it's encouraged that people use tissues to sneeze and cough into, where these are being disposed into standard bins, try and have these bins to have swing lids, or even pedal bins would be better. This is to prevent germs from escaping into the occupied or immediate spaces within the office space or even in the bathrooms. In the bathroom spaces, you can have a choice of separate waste streams and collection services, which may need to be organized to collect contaminated waste separately. Well, to leave you with some final thoughts, this is, again, as Curtis said, this is a new virus and nobody has had prior immunity to it. Therefore, any of the above measures put in place will help reduce the risk of contamination. There are a lot of products emerging in the marketplace that could be potential solutions, but make sure they are. The key thing is to get some advice and don't jump into making significant investment or spend on these without a level of certainty that this investment is going to be valuable. Each building is unique and will need to be assessed individually and a solution tailored for it accordingly. We can help with all of this. With that, thank you for your attention. I will now hand you back to Nachli for the Q&A session. Have a good day and stay safe. Thank you.
Thank you all. That's a lot of information that we've packed in there, gone slightly over, so we've got not a huge amount of time left for question and answers. So if anyone has got any questions, use the chat. If not, obviously because we are tight on time, please just ping us across an email and we can get that answered for you. One that has come through, I think it might have been mentioned because it came through quite early on in the presentation. So adapting modern, flexible, purpose-built offices is comparatively easy. However, many SMEs are operating in small offices, often like ours, in adapted Georgian townhouses or similar buildings, where adaptation to retain social distancing or controlling surface contamination is near impossible due to constrictions within the fabric of the building. So such buildings are likely not to be accessed via lifts or by automatic doors, have no air conditioning other than opening windows, and have narrow corridors. What can be done to adapt these buildings to prevent an immediate second spike as we return to work?
I can talk from an air quality perspective. I mean, I've mentioned it already. Most Georgian houses, I mean, the principles of air quality and viral infection came out of Florence Nightingale and the original Nightingale Hospital. So it's all about opening your windows. You look at sanatoriums, which weren't particularly comfortable places, according to my grandmother, who was in one for a year. They reduced TB risk, which was known to be airborne, by putting people outside. So open your windows and wear a jumper or shorts to work. From an air quality perspective, the ones about movement around the building are a lot harder in that kind of environment. And I think policy is the only way you're going to realistically manage to do it, if you can at all. So any of the things that we've mentioned here will help reduce risk, but none of them, there's no sort of golden silver bullet here. It's still follow the government guidelines first, and if you can't do that, then maybe you need to look at staying home longer, unfortunately.
Thank you. One of the other questions that's come in, obviously we've got lots of different offices. What solutions are your company currently considering in your own offices?
That's a good one, Thomas. I think you were.
Yeah, we've got a whole range of we've got a whole range of office sizes from 4 people up to 250 people. Some of them are in low-rise buildings, some of them are in high-rise buildings. So again, it's just adopting solutions that are going to be sensible and practical in the locations in which we work. So, for example, we don't anymore have a 5-story Georgian building in Edinburgh as an office, but when we did, I could imagine getting people back in there would be quite tricky. They weren't going to be in a lift because there wasn't a lift, it was all just a staircase. But we had a very low density occupancy in the first period until we get to the point in the cycle when the 2-meter rule, I guess, gets relaxed. I guess we're lucky in businesses like ours that a lot of what we do can be done from home. So there's not an immediate need to get back into the confined workspace. And therefore, we should continue following the guidance until such times as it can be relaxed to reduce the overall load on the health services in whichever country we're in. We're seeing some relaxation in countries, as we say, in Australia and in Asia, and the virus seems to be being kept under control, and people are being allowed to get into slightly closer proximity, but not here yet. So we're developing a plan for every one of our offices as to how we'll return, and it'll be on a phased basis.
Okay, thank you. We'll just squeeze one more in there. How can we future-proof buildings to both reduce aerosolized virus concentrations and to be as energy efficient as possible? At the moment, there seems to be a clear contradiction between the two.
I think it goes back to the point that this is a temporary thing. I think you might consider putting in extra capacity should you have this kind of event in future, and that would have an a potential energy efficiency benefit as well. If you're oversizing fans, for example, to deal with an increased fresh air rate to your building, then it's running at a lower capacity, which means it will be more efficient within certain limits. So that sort of thing it doesn't necessarily have to be, they don't have to be contrary to each other. But I still think the main thing to consider is that this is a temporary problem, and climate change is not temporary. So we can put in place some things, most of them around the capacity, which has some cost, but really we need to look at most of the standards that we have aren't actually that bad for the kind of things that for this kind of situation. You look at filtration, everything else, they're kind of suited to it for different reasons, but they still do the job.
Great, thank you. The final point is not a question, just a statement. So as the Legionella risk assessor, please don't be rushed or pressurised to reopening a building. Your Legionella risk assessment will have to be reviewed as a result of reduced occupancy levels, changes in shift patterns, etc., which I think is kind of in line with what you guys have been saying about having the correct policies in place before we do look to open our offices. So that's kind of everything that's come through. If you've got any further questions, I appreciate we've run over time, so just ping them across in an email and we'll get back to you. I'll just quickly say thank you to our speakers, so Ed, Curtis, Kavita and Thomas this morning, and thank you to joining us too. And we'll be saving all of our webinars on YouTube, so you can catch up on them if you've had to jump out or if you want to share them with your colleagues.
Thank you very much for attending, everyone.
Thank you very much.
Thank you.
Okay.
Bye.
Bye-bye.